Alright, hello everyone. So this is a little different video. Today we're going to do a review of the Arduino Uno R4 Wi-Fi board. So we got this about a year ago when it came out because we were excited about some of the features, namely the Bluetooth functionality and Wi-Fi functionality, with the hope that we could integrate this into some of our products to offer Wi-Fi and Bluetooth connectivity without additional hardware. So this is our current spin coder, and it makes use of the Arduino Nano Every board. So this is a great little board for this because it really all it has to do is just motor control and reading the RPMs and talking to their either a computer or a controller or even a mobile device through RxTX connection. What's our take on this board? Alright, so first off, it's the build quality and its overall functionality is really good. And if you're doing any kind of project where you want to get into this kind of microcontrollers, the combination of the hardware and documentation and community support is really unmatched by anything else out there, including some of these ESP32 devices. But again, we were looking to use this in a production or semi-production environment. So does it make sense? Well, let's see. First off, programming. So we have a firmware written for this Nano Every, and so the first thing we tried was to obviously try to compile it for this newer board, and it doesn't work, but that's expected because we are using some of the hardware timers that's unique to this chip versus the new chip that's in the this version of the board. And but there were some instances where it seems like they could have just make migration a lot easier with just API changes. One of those is in the area of pulse modulation. So the motor we use has a built-in controller which takes pulse width signals to control the speed, and generating pulse width controls with Uno R4 or this Nano Every is pretty straightforward. It's just a function call, and surprisingly to us, it was not the same function on this. We had to use a function that's specific for the chip that's used in this, which is kind of surprising because this has enough memory and storage space where just kind of using a wrapper function would have worked easily with that. That was number one. And another area we ran into issues with is with this has, because of AVR microcontroller, has atomic code blocks. This doesn't. Again, with the use of this large language model, ChatGPT specifically, we're able to easily port that. But are we going to go ahead and try to port our code firmware completely over to this? No, because it would take a lot of effort, and again, this was just really for evaluation. And even if we do go into production with it, the addition of Bluetooth or Wi-Fi really doesn't add much to this product. And if it's Bluetooth or Wi-Fi, we could add those functions with external module, which brings us into this ESP32 Arduino lookalike. So this has the same form factor as pretty much the Arduino, this Arduino Uno R4, but it's powered by ESP32, so it gives you Wi-Fi, also Bluetooth. The only downside to these boards, and I think I don't know why these companies don't think about this, is that it is 3.3 volt logic level, and we really need 5 volt logic level. So I'm hoping to see a company who does a ESP32 board with 5.5 volt logic level. So there was no real attempt made to completely migrate our current firmware from the Nano Every into this board. However, we did do a scaled back version of this firmware which just aims to control the motor itself, and overall that works pretty well. Again, we connecting this over the BLE connection to the Bluetooth connection. You do have the I think the other big addition to this is this LED array, so that could be used to display the speed and when it's accelerating. However, this additional functionality is for the market we sell this product into, it's not that in demand. So it would just be so nice to have, but overall, there's no real value in us even attempting to migrate to this platform, because if we do need additional Bluetooth or Wi-Fi functionality, it's much easier just to use one of these ESP32 boards as a go-between the Nano Every and the Bluetooth or Wi-Fi device. So while we're in the topic of Bluetooth, let's discuss one of the big differences in Bluetooth and why it's relevant in a production setting for a particular device. So the Bluetooth that's supported by this Uno R4 is only BLE. So what is BLE? That means that it really communicates really well with, say, a mobile device, or certainly in Apple iPhone devices. But before BLE, there was another protocol that's used for communication, RxCS communication, and it's called SPP or RF COMM. So RF COMM is not supported by Apple devices, but for our use case is connecting to a mobile device isn't really a big deal. What it is, a bigger deal is connecting to a desktop computer, and this is where classic Bluetooth or RF COMM has a lot of advantages over BLE, because RF COMM or classic Bluetooth, from the computer standpoint, this looks like another serial port. So there's no additional software or additional drivers to install if you wanted to set up a connection between, say, like this ESP32, which does support RF COMM, classic Bluetooth, and the computer. So it's completely transparent and it works really well. With BLE, we only found one piece of software that worked on Windows, and it didn't work that well. So to summarize things, if you just want a nice microcontroller board to work with, I think this Uno R4 Wi-Fi is a really good board. But if you're looking for something to put into production which has Wi-Fi and Bluetooth, this definitely is not the board, and I don't think it was really meant to be that kind of board. I think you'll be much better off if you need BLE or Wi-Fi going with an ESP32 board, with logic level shifters to communicate any 5-volt devices or sensors you have.